Hello everyone. The headline of this tutorial is rate of change. We have some notes before we start solving the examples and the exercises. The continuous velocity of a moving body at an instant is the derivative of the position function of this body. At the instant t, the velocity of t equal to limit delta t approach 0 of the position function s of t plus delta t minus s of t over delta t, which it is the derivative of position function. The average velocity of a body during the interval t2, t1 is v sub a, change in position s of t2 minus s of t1 over change of time t2 minus t1. Note the function s of t equal to t squared minus 5t plus 4 is the position function of a point moved on x-axis, where t is the time in seconds and s is the distance in meters. Note the velocity is not only the speed of the point, but it is also indicates direction. If the velocity is negative, then the movement is in the negative direction of x-axis. The speed equal to absolute value of velocity. Note when the question say during the first 4 seconds means t1 is 0 and t2 is 4. If the question says during the first 3 seconds means t1 is 0 and t2 is 3. Note, the point moves to the right when the velocity is positive, and to the left if the velocity is negative, and stop if the velocity equals 0. The acceleration is the derivative of velocity. To find the acceleration, derive the position function twice or derive the velocity once. If s of t is the position function, then the velocity function v of t equal to s prime of t, and the acceleration function a of t equal to v prime of t equal to s double prime of t. Example, what is the average velocity of the point during the period t1 equal 3 to t2 equal 7? What was its instant velocity at t equal 5? The average velocity equal to s of t2 minus s of t1 over t2 minus t equal to s of t2, s of 7 minus s of t1, s of 3 over 7 minus 3 equal to 7 squared minus 5 times 7 plus 4 minus 3 squared, let me write it here, minus 5 times 3 plus 4 over 4 equal to 7 squared, 49, minus 35 plus 4 minus 9 minus 15 plus 4 over 4 equal to 49 minus 35, 14 plus 4, 18 minus 9 minus 15, negative 6 plus 4, negative 2 times negative, it will be plus 2 over 4, 20 over 4 equal to 5 meter per second. This is the average velocity of this point. what was its instant velocity at t equal 5? The velocity equal to v of t equal to s prime of t equal to 2t minus 5. At t equal 5, then v of 5 equal to 2 times 5 minus 5 equal to 10 minus 5 equal to 5 meter per second. What is the average acceleration of the point between t equal 3 and t equal 7? The acceleration function equal to v prime of t equal to, this is the function or equation of velocity, equal to t. It is the average acceleration of the point. Example, but before we study this example, we have a note. A model of vertical motion is s of t equal to negative 4.9 t square plus v naught t, where v naught is initial velocity, plus s naught. S naught is the initial position. Here where the ground acceleration is 9.8 meter per second square, velocity unit is meter per second, and the distance unit is meter. S of t equal negative 16 t square plus v naught t plus s naught, when the ground acceleration is 32 feet per second square, velocity unit is feet per second, and the unit of distance is feet. Example, in a firework festival, a rocket is launched upward from the height of 2.5 meter of the ground at initial velocity of 49 meter per second. Needed A, write the position function for the motion of the rocket. Since the distance is in meter and velocity is in meters per second, then the position function s of t equal to negative 4.9 t square plus initial velocity 49 t plus initial distance 2.5. Needed to, what is the height point the rocket can reach? The height point the rocket can reach is when the velocity v of t is equal to 0. Then we find the velocity function equal to derivative of position function equal to 2 times negative 4.9 negative 9.8 t plus 49. Set it equal 0 and find the time when the velocity is 0. 9.8 t equal to 49, then t equal to 49 over 9.8 equal to 5. Then substitute 5 in the position function to find the height point that rocket can reach, equal to negative 4.9, 5 square plus 49 times 5 plus 2.5 equal to 125 meter. This is the height point the rocket can reach. Needed C, what is the velocity of the rocket when it reaches 120 meter? Set the position 120 in the position function to find the time. Negative 4.9 t squared plus 49t plus 2.5, then 4.9 t squared minus 49t plus 117.5. We'll use the quadratic formula to find the value of t. T equal to negative b minus plus square root b squared minus 4a times c over 2a equal to negative b, negative 49, negative positive square root b squared 49 squared minus 4 times a 4.9 times c 117.5 over 2 times 4.9. Solve this algebraic operation to find t equal 4 and t equal 6. When t equal 4, then the velocity v of 4 equal to, substitute 4 in the velocity function, negative 9.8 times 4 plus 49 equal to negative 9.8. Positive 9.8. When t equals 6, then v of 6 equal to negative 9.8 times 6 plus 49 equal to negative 9.8. Then the velocity is 9.8 when the rocket moves upward, and minus 9.8 when the rocket moves downward. When will the rocket need d? What is the acceleration of the rocket at each instant? The acceleration is the derivative of the velocity function that is found here. The acceleration function equal to negative 9.8 at each instant. When will the rocket reach the ground? When will the rocket reach the ground? The rocket reach the ground when the position function equal 0. Then set in the position function s of t equals 0 and find the value of t, negative 4.9 t squared plus 49t plus 2.5. Use quadratic formula to find t equal to negative 49, negative positive square root 49 squared minus 4 times a, negative 4.9 times 2.5 over 2 times negative 4.9. Then t will be negative 0.05 and t equal to 10.05. We will neglect the negative value since the time is always positive. Then after 10 seconds, the rocket will reach the ground. Example or exercises number 3. Use the figure of the velocity in the right to answer this question. A. At what time will the particle start moving to the left. The particle moving to the left when it is under x-axis. Then it is moving to the starting moving to the left in the interval 1 to 5. So A, the particle starting moving to the left, moving to left, and the interval 1 to 5 when the graph is under x-axis. To the right, when the graph is over x-axis, from 0 moving to the right, from 0 to 1 in the interval, and from 5 to 7. At what time will the velocity increasing? The velocity increasing either when the velocity is negative and decreasing, or it is positive and increasing. So in the interval 1 to 2, velocity increasing in the interval when it is negative and decreasing, in the interval 1, 2, and it is positive and increasing 5 to 6, interval 5 to 6. When will it decreasing? Velocity decreasing when it is positive and decreasing in the interval 0, 1, or negative and increasing, negative and increasing in the interval 3 to 5. At what time will the acceleration of the particle be positive, negative, or zero? The acceleration of the particle is positive when the velocity is increasing. Velocity increasing is between 3 and 6, as you see. So the acceleration is positive when the velocity increasing between 3 and 6. Acceleration is negative when the velocity decreasing between 0 and 2. Between 0 and 2, the velocity decreasing, and between 6 and 7, also the velocity decreasing. 0, the acceleration is 0 between 2 and 3. Acceleration is 0 in the interval 2 to 3 and 7 to 9. When the graph is a horizontal line parallel to x-axis. At what time will the velocity be at its maximum? As you see, here we have the maximum velocity at negative 2. The particle reaches negative 2, moves left, and at when t equals 0. Therefore, the maximum velocity is when t equals 0 and t is between 2 and 3. At what time will the particle be at rest for more than one moment? The particle will be rest more when it moves over x-axis. Here it's moment. Here also it's a moment. From 7 to 9, it's more than a moment. Then the particle at rest, rest 7 in the interval 7 to question 9. Number 7. I skipped those solved in the ministerial question because they are repeated. Question number 7. A particle moves on the graph y equal sine x. Find dy over dt at x equal pi over 6, x equal pi over 4, and x equal pi over 3, where dx over dt equal to centimeter per second. The chain rule is use chain rule to find dy over dt equal to dy over dx, since y is given in x variable, times dx over dt. Then dy over dx, differentiate y with respect to x, a derivative of sine x is cosine x, times dx over dt, it is given 2. Therefore, y prime or dy over dt equal to 2 cosine x. At the point pi over 6, then y prime of pi over 6 equal to 2 cosine pi over 6 equal to 2 times square root 3 over 2 equal to square root 3. At x equal pi over 4, find pi prime of pi over 4 equal to cosine 2 times cosine pi over 4, and at the point pi over 3 equal to 2 cosine pi over 3. Question number 8. Find the rate of change of the distance between a particle moving on the parabola y equal x squared plus 1 and the origin, given that dx over dt equal to centimeter per second. The formula of distance between 2 points is d equal to square root x minus x1 square plus y minus y1 square. Here the point x1, y1 is given origin point 0, 0. Substitute this point in this formula, then d equal to square root x minus 0 square plus y minus 0 square equal to square root x power 2 plus y power 2. Now, find the derivative of d with respect to t. D of d with respect to t equal to, first let us convert this function in the variable of x only, equal to x power 2. Since y is x power 2 plus 1, then y square is x power 2 plus 1 square. Now d is only in x variable. Now find the derivative of d with respect to t equal to d of d with respect to x times d of x with respect to t. using chain rule. Now differentiate this square root, derivative of the term inside of the root in the numerator 2x plus 2 times x power 2 plus 1 times 2x, the derivative of the bracket, over 2 square root x power 2 plus x power 2 plus 1 square times dx over dt, it is given by 2, equal to, factorize the numerator or reduce 2 with 2 and open this bracket, 2x plus 2 times 2, 4x times x squared, 4x power 3, 4x times 1, 4x over square root x power 2 plus, open this bracket, x power 4 plus 2x power 2 plus 1 equal to 2x plus 2x, 6x plus 4x power 3 over square root x power 4 plus x power 2 plus 2 x power 2, 3x power 2 plus 1. This is the final answer. Question number 9 is the same as the number 8. Find the rate of change of the distance between a particle moving on the graph of the function y equals sine x and the origin where dx, sorry, by dt equal to centimeter per second. The distance formula equal to square root x minus x1 square plus y minus y1 square. x1, y1 is 0, 0, then d equal to square root x power 2 plus y power 2. Here y equal to sine x, then d equal to, write d in term of x only, x power 2 plus sine square x. Differentiate d with respect to d over dt equals d over dx times dx over dt, chain rule. Then differentiate this function with respect to x, d over dt equal to 2x plus 2 sine x times cosine x over 2 square root x power 2 plus sine square x equal to, factorize by 2 for the numerator, 2x plus sine x cosine x over 2 plus sine 2 times square root x power 2 plus sine square x times, we forget, dx times dt, it is given to, also here multiply all this bracket by 2, then reduce 2 with 2 equal to 2x plus 2 sine x cosine x over 2 square root x power 2 plus sine square x. Sorry, 2x plus 2 sine x cosine x over square root x power 2 plus sine square x equal to 2x. 2 sine x cosine x is sine 2x from the roots of trigonometric function over x power 2 plus sine square x. Question number 12. Satellite in space can measure the angle theta as shown in the figure, where h is the distance between the satellite and the center of the earth, and r is the radius of the earth. Needed A. Show that h equal to r times 1 over sine theta minus 1. In the right angle triangle, the sine theta equal to opposite r over hypotenuse r plus h. Then r plus h equal to r over sine theta, cross multiplication. Then h equal to r over sine theta minus r. Then h equal to factorize by r 1 over sine theta minus 1. This is the pairs needed. Number 2b, find the rate of change of h with respect to theta at theta equal 30 degree. Take r equal to 6,373 kilometer. The rate of change, differentiate h with respect to theta, dh over d theta equal to r is constant, then differentiate 1 over sine theta with respect to theta, denominator times the derivative of numerator 0 minus the numerator 1 times derivative of the denominator cosine theta over sine square theta minus 0 equal to r cosine theta over sine square theta. Rate of change at theta equal 30, then h prime of 30, substitute every theta with 30 and take r 6,373 times cosine 30 over sine square 30 equal to negative r cosine theta negative equal to negative 6,373 cosine theta square root 3 over 2 over sine theta sine square 30 1 half square 1 over 4 equal to negative 6,373 times 2 square root 3 equal to negative 12,746 square root 3. The last question in this set, the other question I solve it within the ministerial question because they are repeated. Question number 13, y equal ax plus b, where a and b are two real numbers. Suppose that x and y are function of t and the rate of change of x is constant. Is the rate of change of y also constant? If yes, are the two rate of change x and y are equal? let us see. Suppose that the rate of change of x with respect to t is constant. Suppose it is equal to k. dy over dt equal to dy over dx times dx over dt by chain rule. Then dy over dt, rate of change of y equal to dy over dx a times k. Therefore, also the rate of change of dy of y is constant. From this equation, dy over dt equal dy over dxa times dx over dt. If dx over dt equal to dy over dt, then a equal 1. Therefore, the two rate of change are equal in case of when a equal 1. See you next lesson.